Okay, so we've proven properties 1 and 2 using the axioms. Those two properties are now available for our use in proving other properties and so forth. I'm going to let you think about how to prove properties 3, 4, and 5. All right, and again, you can use the axioms, and you can also utilize properties 1 and 2 if you need them. So think about that and do some work on it, and we may talk about that a little bit later. Right now what we're going to do is we're going to start looking at properties of the odds function. All right, and remember that the odds of an event are they're given by the probability of the event divided by the probability that the event does not occur. All right, odds are another way of quantifying the likelihood of some event. Okay, so if we think about what we just looked at, in particular, the complement rule, the probability of an event and the probability of the complement of the event always sum to 1. All right, and that result, as we just saw, is the complement rule. Now, odds have a similar property, but instead of involving their sum, it involves their product. Specifically, the product of the odds of an event and the odds of the complement of the event will always be 1. Right? Notationally, we write that this way. The odds of A times the odds of A complement will always be equal to 1. And so that implies, for example, if we want to solve for the odds of A complement, that would imply then that the odds of A complement are equal to 1 over the odds of A. Or equivalently, the odds of A are equal to 1 over the odds of the complement of A. So in other words, the odds of the complement of an event is equal to the multiplicative inverse of the odds of that event. Now we look at a particular property of the Logit function. Remember that the Logit is the natural log of the odds. Okay, and so as discussed above, the product of the odds of an event and the odds of the complement of the event will always be equal to 1. Logits have a similar property, but it involves their sum. In particular, the sum of the logit of an event and the logit of the complement of the event will always be 0. So written mathematically, we would express it this way. For a given event A, the logit of A plus the logit of A complement will always be equal to 0. And so if we solve this equation for the logit of A complement, then that would tell us that the logit of A complement is going to be the negative of the logit of A. In other words, the logit of the complement of an event is equal to the additive inverse, in other words, the negative of the logit of the event itself. And this actually has application in logistic regression. So in logistic regression, what we're doing is modeling a dichotomous outcome, an outcome that has two possible values, two possible levels. And if you do your logistic regression using one level as the primary level of interest, then you'll get a result, you'll get a model, all right, with coefficients, regression type of coefficients. If you wanted to change the level of interest, if you wanted to, instead of modeling level 1, you wanted to model the second level as the primary level of interest, then all you'd have to do is just change the sign of the coefficients, and that would give you the new set of coefficients.